Assalamualaikum everyone. This is Group 1 consisting of roll 66 to 71. Here we are presenting our project. Our project name is Generation of Power from Wind Turbine. This is the diagram of our project. In this project, we provide variable wind speed with time, then pass it to a wind turbine. From the wind turbine, the mechanical energy flows to the permanent magnet synchronous generator and convert it to the three-phase AC electric power. Then we pass it through a rectifier and convert the AC voltage to DC voltage. Then we have used a boost chopper to convert the different DC voltage level that have been got from the variable wind speed to a constant DC voltage level. Here the controller is to nullify the oscillations. After that, a pulse width modulation inverter is used to convert that constant DC voltage to 50 Hz AC voltage and pass it to the load. So this is our schematic diagram of the project that we have built using MATLAB Simulink. Practically, wind speed is not constant all the time. That's why we have used pre-built signal builder block to provide variable wind speed as the input signal. We can see here different level of speed changing with time.
In this part, we'll be converting wind energy to mechanical energy using a wind turbine and a permanent magnet synchronous generator. For wind turbine, we'll be using a wind turbine pre-built block in Simulink. This block implements a variable pitch and a turbine model. The first input is the generator base speed in per unit system. For a synchronous or asynchronous generator, a base speed is the synchronous speed. For permanent magnet generator, the base speed is defined as the speed producing nominal voltage at no load. The second input is the blade pitch angle beta in degrees, which is the rotation along the blade axis. The third input is the wind speed in meter per second. Finally, the output is the torque applied to the generator shaft in per unit of the generator. For synchronous generator, we'll be using synchronous machine pre-built block in Simulink. This block implements a 3-phase or a 5-phase permanent magnet synchronous generator. The stator windings are connected in Y connection to an internal neutral point. A 3-phase machine can have a sinusoidal or a trapezoidal back EMF waveform. The rotor can be round or a salient pole for sinusoidal machine. Finally, we'll be using a preset generator having 0.8 Newton meter torque with 300 VDC and 3000 RPM with 0.8 Newton meter torque input from the wind turbine. Now let's have a look at the output of the synchronous generator. As expected, the output of the synchronous generator is a 3-phase sinusoidal signal.
The 3-phase AC voltage generated from the permanent magnet synchronous generator is now fed to a 3-phase AC rectifier. We have used the pre-built AC rectifier in the Simulink, which is basically consisting of 6 diodes. A resistance capacitor and a Zener diode is connected to the rectifier in parallel connection. The rectifier will convert AC signal to a single DC signal. To minimize ripple voltage, a capacitor is added. The Zener diode then converts the signal to a smooth DC level. Now we can see the output. As we can see, the output is changing after 0.3 second, 0.6 second. This is due to the fact the 3-phase AC voltage generated from the permanent magnet synchronous generator was changing after this time period.
To generate a sinusoidal wave with certain voltage and frequency, we need a certain DC value. But here, due to variation in wind speed, we have got different DC voltages. So to get a certain value DC signal, we have used DC to DC step-up boost chopper. Here, the MOSFET is operating as a switch. At first, it is off. Then the current is passing through diode and the capacitor is being charged. When the voltage of capacitor is almost equal to the source voltage, then the diode gets reverse biased and the switch is closed. Then the current flows through this circuit and magnetization is created in the inductor. The switch is closed all on a sudden, and due to abrupt change in the current of inductor, there is an induction of voltage in inductor which is added with the source. Then the diode is again forward biased and the capacitor is being charged again. So the voltage of capacitor has become greater than the source voltage. Here, the output for our project is 300 volt.
Now we use inverter to convert 300 volt DC to AC. Inverter uses pulse width modulation method to convert DC to AC. Here, MOSFET is an important element. We implement pulse width modulation by controlling the gate voltage of MOSFET to keep it on or off a certain portion of the cycle. We need 2 MOSFETs to create a single phase. Here, 6 MOSFETs are used to create 3-phase voltage. Now, the number of times the MOSFET turns on or off is called switching frequency. Here, the switching frequency is 6750 Hz. We take 3 sine waves of 50 Hz as the reference, and they have 120-degree phase differences between them. We compare it to the triangular signal, which is called carrier signal. It has switching frequency. The peak value of carrier signal is 1, and the peak value of reference signal is 0.8. So the modulation index is 0.8. When reference signal's amplitude is greater than carrier signal's amplitude, the MOSFET turns off and the other MOSFET turns on in the same arm. This way, we create 3-phase AC from the 3 arms of inverter. This AC we created is not smooth, so we add an LC. So we add an LC branch to smooth the AC signal. Here the value of inductor is 47.7 millihenry and the value of capacitor is 0.32 millifarad. Now we can check the value of output in the scope. We see that the output is 3-phase having 120-degree phase difference, and it has 150 peak value, and the frequency is 50 Hz.
Now comes the load part. The load part is connected with the output of the wind turbine power plant through a transformer. This transformer is a step-up transformer, as power transmission lines require high voltages to decrease power loss through these lines. Feeders are inserted here as transmission lines to supply electricity to industrial loads and substations. The substations are connected with grid through step-down transformers to supply electricity to local loads.
In this project, our main purpose is to generate power from the generator. From the 3-phase output voltage and current of the generator, we have taken RMS value and plotted the power. From the graph, we can see the generated output electrical power from the mechanical power, and its peak value is 13 kilowatt. So the presentation for our project ends here. Thank you everyone.